Okay, in the last section, I call this 3-6B because we're just doing one more example. I just don't want to cram it into one lesson on the other one, so I thought I would take our time and just kind of split them up a little bit. This time we're going to talk about the distance between two parallel lines. And you probably see these every once in a while. You probably see a ladder, and a ladder kind of describes what we're doing right here. These two posts right here would be the parallel lines, and the little spokes between them would all be equidistant. Now this is slanted a little bit. They kind of drew this so it's a little bit of an angle. So if I actually measured these, that looks like it would be a little bit longer than this. But if it was a true ladder, okay, ladders would be, these two rails right here would be parallel to each other, and each distance from here to here would be equal. So all these segments would be equal to each other. What would it look like if you had a ladder where that did not happen? Well, I just found one on the internet. Look at this crazy old ladder. All right, these lines right here, not even lines, okay? So I wouldn't even consider them being parallel to each other because they're not even lines. And look at the rungs between them. See how the different distances? If you wanted to be a little more geometric, right, we could do this, and we'll copy and paste it and put it over here. And watch this. If I was to, let's make this another color. If I was to pick any point on here, let's say right there. If I wanted to find the distance between the two parallel lines, let's say those two lines are parallel, and if I wanted to find the distance between them, it wouldn't be here, it wouldn't be here, it wouldn't be here. What would the distance be? It would be the perpendicular distance. Okay, this time we're not necessarily going from a point, we're going from one line to another, or one parallel line to another parallel line. And this right here would be the distance between the two parallel lines. Well, look, that distance would be the exact same distance. Let me just scooch it down. Watch, see, if I keep scooching it down all the way, that doesn't change at all, right? It doesn't overlap or anything. It stays the same all the way through here. So that distance is going to be the same no matter where you decide to put it between those two parallel lines. All right, let's put it back up here, and you can kind of see that's like one of the rungs in the ladder. And so an ideal ladder, all those little rungs would be the same distance apart if you had an ideal ladder. Now, of course, you have that stick ladder, probably not the case. So what are we going to do? We're going to do an example. We're actually going to give you two lines. They're going to give you the equation of two lines, and you have to find this distance between the two lines. They'll give you the equations of these two. They're not necessarily going to be straight up and down like this, okay? But you want to find the distance between those two parallel lines. So let's go to the graph paper. I think that's a little easier to work with. And then we'll do that example. And that's all we're going to do. We're going to do that one example, and that's it. Okay, here's the question they're going to ask you. They're going to ask you something very similar to this, if not exactly this. They're going to say, find the distance. Okay, that's what you're trying to do right there. Whoops, I'm writing in white. Let's write in a color I can see. Find the distance between the parallel lines L and M with equations y equals 2x plus 1 and y equals 2x minus 3. So this L is this equation and M is this equation. They put the word respectively after it, meaning this goes with L and the second one goes with this second one, M. So what we're going to do is we are going to graph both of these. That's why I put the graph paper on here. Okay, so we're going to graph both of them, actually. We'll do one in orange since I picked orange, and let's go green. Go Irish colors. All right, so there we go. Let's do the orange one, and then we'll do the green one, and we'll see what they look like. If you notice something right away, they both have the same slope. So what does that mean is going to be true about these lines if they have the same slope? Well, that means if the two lines that have the same slope are going to be parallel to each other. And they tell you they're parallel, but I could have told you they were parallel just by looking at the slopes. So we know we're going to have parallel lines. So let's graph it. This first one, y equals 2x plus 1. That means there's a y-intercept at 1. And then the slope is 2. So rise 2, run 1. And let's connect those two. And we'll extend it out a bit like that. And then we'll extend this one like that. All right, just to give it some length. And let's now do the green one. So it's y equals 2x minus 3. So my y-intercept is 3. 1, 2, 3. So it's going to be right here. And the slope is 2 again. So I rise 2 and I run 1. and I'm going to connect those two. All right, try to be pretty careful with this. If you use graph paper, it's very, very helpful. All right, so there's my two lines. I have my orange one and I have my green one. And this is L and M, so that's M, and this is L. But I might just refer to it as the orange one and the green one. Let's see. So what in the world are we going to do? Well, the thing is, I want to find the distance between these two. So remember, I pick anywhere on this line and I draw a perpendicular line between the two. But the key to this is where to pick the point that you're going to start from. Pick a point that you actually know the coordinates of that point. You know for sure what that coordinate is. There's a couple points. There's all kinds of points you could pick probably, but here's two. I would pick the intercepts. I think that's the easiest thing to do. So this orange one has a y-intercept right here, and the green one has a y-intercept right here. You could pick either one of those. Okay, it doesn't really matter which one you pick. I'm going to pick this one right here just because the book does. And what I'm going to do is I want to find the distance from this point to this line, and that's going to be very similar to what we did in the other video, the first part of 3-6, finding the distance from a point to a line. So let's draw it first. Remember the other equation or the other problem? It looked like it hit right on one of the points, and we said, oh, you know, it looked pretty easy. So I'd say, I'm just eyeballing it, I'd say about right in there somewhere. I might be off just a little bit. Yeah, maybe it looks, let's do this. Let's try that again. I know I'm being a little bit picky, but let's say, I don't know, about right in there, I guess, somewhere in there. So we want to find the length. Let me stretch it out just a little bit so it touches. There we go. I want to find the length of that line. Well, I know a point. How did I know that point? Because it's the y-intercept to this green line, and the y-intercept is -3. So that point is 0, -3. Here's the deal. This is the part that you're really trying to do. Okay, everything else is pretty easy. I should say this. Everything leads up to finding this point. This point right here is super, super important. Because remember what I'm trying to do. I'm trying to find the distance between these 2 points. The distance between these 2 points is going to be the same as the distance between any 2 points up here. All right, because remember the rungs of the ladder are the same length. So I want to find that distance. So the problem is to find that x and y. Well, that x and y, it's the intersection between the red one and the orange one. So what I'm going to do is I'm going to find the equation of both of those lines, the orange one and the red one. Well, it's kind of nice because I already know the equation of that orange one. They told it to me right here. So let's just write it down. I didn't have to do any work to figure that out. I'm going to put it in a box because I'm going to use it later. I think it's good to put it in a box. I like that. So that's the equation of the orange line. Now what I have to do is I got to find the equation of this red line right here. Every time I say that, I think I'm saying red lion, but it's a red line. Okay, so that's what I want to find. So how in the world can we find the equation of this red line? Well, y equals mx plus b, right? That's the equation of a line. And what do I know for this red line? Well, I know a point. I know an x and a y, so I can put that x here and that y here. Let's see, what else do I know? Do I know the slope? Do I know the slope of this red line? I can't really count up and over because I don't know what that point is, but I do know the slope of the green one. Look at the green one or the orange one. They're both the same. Look at the green one and look at the red one. What is the slope of the green one? The slope of the green one is 2. Since these are perpendicular, okay, remember, if it's the distance, it's perpendicular. Since they're perpendicular, the slope of the red line is going to be the negative reciprocal of the slope of the green one. So the slope of this is 2. So my slope, the slope of the one that's perpendicular to it, is going to be the negative reciprocal. So this was positive, so it's now negative. It was 2, or 2 over 1. What's the reciprocal? It's 1 over 2. So look at that. So now I know the slope of the red line because I knew the slope of the green one and I knew they're perpendicular, so now I take the negative reciprocal of this green one, and I've got the slope of the red one. All right, see how it all comes together from the stuff we were supposed to learn before? So hopefully if you learned it before, then it all kind of comes together, and it's pretty cool now. So look at this. The x is 0, so I'm going to put a 0 in for this x, and I'm going to put a -3 in for the y, and I'm going to put a -1/2 in for the m. So let's do that. Y is -3, and then I'm going to solve for b. So I put a -3 in for y equals m, which is -1/2, times x, which is 0, equals b. All right, so now what I'm going to do is I want to find, let's see, did I do that right? Yeah, I did it right, but I went through a whole lot of stuff you didn't really have to do because I already know the y-intercept. Some of you guys are thinking, no, the y-intercept is -3, Mr. Hamrick, why are you going through all this? But you're absolutely right. So watch, -1/2 times 0 is 0, so b is -3, just like it should be. Now I kind of went through a thing right here that I didn't have to do. Because look, I could have just told you that the y-intercept was -3. So let's find the equation of the red one. I'm ready now to write the equation of the red line. So y equals m, which is -1/2, and then an x, and then the y-intercept, which is -3. And I'm ready to put that one in a box. The reason I'm putting it in a box so I don't forget about them. See these two equations right here? What I want to do is I want to find the point of intersection between these two equations, and that's this point right here. See, this orange one and this red one, they come together right here, and if I solve for the x and for the y of those two equations, I'm going to find that intersection point. I'm going to find that x and y. Once I find the x and y, I can find the distance between this point and this point. So I got to find x and y. So let's take those and let's solve for x and y. Okay, here are the two equations that we had on that other page. And remember, since they're both equal to y, they're both equal to each other. So I could take 2x plus 1 and set it equal to -1/2 x minus 3. And now I just solve for x. Add a 1/2 x to both sides. Add a 1/2 x to this side. That goes away. Let's subtract a 1 from both sides, and let's see what we get. We get 2.5. But what's 2.5? Let's write that as an improper fraction. That would be 5/2. It's a little easier to work with an improper when we do algebra. So that would be 5/2 x, that canceled, equals -3 minus 1 is -4. Let's get rid of the 5/2, and I do that by multiplying by the reciprocal. It's just basic algebra stuff. It's 2/5. And let's see what I get. Does anything cancel out? Nope, 5 doesn't go in anything, so I have to write it as -8/5. -8/5. Okay? So that's what x is. You think, oh, that's not pretty. Well, remember I told you in the other problem, on the other video, they're not always going to come out pretty. So this one doesn't come out real pretty. But let's do this. We're not done yet. We still need to solve for y. So now let's solve for y. I'm going to take this x. I'm going to plug it into either one of these. It doesn't make any difference which one you use. Let's use this top one. All right? It looks like it might be a little easier to deal with. Or it might not, because you got a half and the 2 will go into the 8. I'll tell you what. Let's use this. I bet you most of you guys would be scared off from using this because you got the fraction, but it actually might work out a little bit easier. So what are we going to do? We're going to go y equals -1/2 times x, which we just found, which is -8/5, and then minus 3. So let's see what we get. Negative times negative is going to be positive. Look, the 2 goes once and the 2 goes 4 times. So look what we have. We have 4/5 minus 3, or 3/1. What I'm going to do here is find a common denominator, and that would be 5. So I don't change that. 1 times 5, 3 times 5 is 15, and that would be -11/5. And that's what y is equal to. You can go back, pause, and try it yourself, okay? I showed you every step. I explained every step to you. I know the fractions bother a lot of people. You're going to have to take some time and go through it and figure out what I just did right there. Now, what's nice is the book does this. They write it as a decimal, okay? Because it comes out to a decimal that actually stops, to a finite decimal, okay? So let's see, -8/5 would be the same as -1.6. Okay, and then y would be the same as negative 2.2. That makes it a little bit easier to do what we're going to do here. So let's figure out what in the world did we just find right here. Well, we actually found an ordered pair, and it's negative 1.6 and it's negative 2.2. What I'm going to do now is I'm going to take this and I'm going to put this onto that graph paper. Okay, here we are back here, and remember we were trying to find that point right there. So where is it? It's actually this point. Now again, remember I said I probably wasn't real accurate with this, and that's why it's good to do all the math here, because you can't just always guess. Where's this point located? It's negative 1.6. Here's negative 1, here's 0.6, so I was off just a little bit, and it's 2.2, so it probably should be down in here. So this probably should have gone to about here. But that's the beauty of this, is you don't have to be perfect on this, because I was just kind of guessing what would be perpendicular. Okay, so really if the point was about around in here somewhere, then I connected it. That would have been a perpendicular. Okay, that would have been a nice perpendicular. But that's okay, all we want is the point anyway. So what are we trying to do? We are trying to find the what's the whole object of this? Find the distance between the two lines. So I want to find that distance between here and between here. Well, how do I find the distance? Let's stay with the graph paper right here. We'll keep moving around. How do I find the distance between 2 points? And what are the 2 points, by the way? The 2 points are 0, 3, and negative 1.6, negative 2.2. So I want to find the distance between them. So I do the distance formula. And definitely use a calculator for this stuff. Subtract the x's from each other, so it's 0 minus negative 1.6. And then subtract the y's from each other, it's negative 3 minus negative 2.2. I'll let you do all that. Okay, plug all that into a calculator, let you do the work, and you get around, it'll be an estimation, but you'll get around 1.8 if you round it. Okay, they just rounded it to the first decimal place, and you should get about 1.8. So what in the world is that? What did we just find? We found the distance of that little red segment right there. It's 1.8 units. That's how long that line is, and that's what they are asking you to do. They are asking you to find the distance between the parallel lines. Now that distance will be the exact same distance as anywhere along this line. It's going to be the same exact distance. Well, that was a little lengthy. It took 18 minutes just about to explain, well, not just that problem, I explained some other things before, but it shouldn't take you that long to do the problem. Okay, I went through all the explanation, but I promise you, you're not going to know how to do this unless you go through this exact example. Just write this down on a blank sheet of paper and try to go through what I did. If you get stuck, go back to the video, find that spot in the video, and figure out what you're supposed to do. Don't try any of the homeworks until you've actually done this problem on your own. Once you've done that, then I think you're ready to try some other problems that are very, very close to this. All right, that was a little bit tough. Okay, as far as the math goes, that's probably one of the tougher ones as far as the number of steps and that kind of thing in geometry that we're going to do, to tell you the truth. But give it a shot, okay? Give it a shot and try your best. Okay, I'll stop talking and enjoy the rest of your night.